In this lab, we're going to look at the nature of light. And in the previous labs that we've done, we've actually looked at light and how it interacts, lenses, diffraction, all that good stuff. However, we've never really looked at how light is produced. So we're going to actually examine a little bit of that today. The first thing that we're going to do is we're going to look at, say a light bulb, a normal light bulb that you would see. And I know that incandescent light bulbs are on their way out, but the lights that are filming me are really bright incandescent lights. So I have a wonderful little thing. This little box is a spectrometer. And it'll tell me, if you don't know how a spectrometer works, a spectrometer will tell me what light is being produced. So what colors of light and how bright each of those colors are. So when I hold up this little fiber optic, which will take the light and put it into the spectrometer, when I hold it up, for instance, to the incandescent light, this really bright light bulb with a filament in it, you'll see this spectrum show up. And this is a snapshot of the spectrum. And you'll notice that it's got this wonderful little curve to it. This is what we call a black body curve. And it has pretty much all the colors in it and a nice kind of smooth look to it. Well, if I were to go outside and do the same thing, this is something that, I'm in a lab right now in a studio shooting this, so can't actually do this, but I'm going to go outside. If I get a spectra from it using the same device, it looks something like this. And if you notice, the two look very, very similar. And the sun is a black body source, just like the incandescent light. And the lights that's produced from both are produced both in a relatively the same exact way. So it's kind of a nice little thing. Well, there's other types of light that we can do. And if you've ever noticed fluorescent lights, they look a little bit different than incandescent lights. The colors look just a little bit different, sometimes a little bit more blue for the fluorescent. So I'm going to take this thing, and above me there is some fluorescent lights. So I'm going to shine it up at the fluorescent lights. And you'll notice that the spectra that I get from the fluorescent light looks a little bit different. So the snapshot doesn't have that necessarily black body characteristic to it. It's not that smooth characteristic that we saw before. That's good and all. Now we see in fluorescent lights, we've seen black body. But the one that we're really interested in today is actually going to be using this other little device that's sitting here. We have these wonderful little glass tubes that contain a gas. And the gas, when you put these in, this is a discharge tube. And this is actually similar to what you'll see for neon signs. This is not neon. This is hydrogen, if I'm not mistaken. So when I turn this on, you'll see the color, this wonderful little purplish color show up. When I put the spectrometer up to it, you'll see that the light that I produce here is very, very narrow peaks of light. So we see probably about 4 different peaks, depending on how good I do with this. See about 4 different peaks, and this is for hydrogen. We get these characteristic peaks. It doesn't matter what hydrogen we're looking at. It's in a glass tube. The stars will be produced by hydrogen lines. Meteors we can determine. What it really comes down to is that each individual atom has different energy levels. Maybe in chemistry you learned about different energy levels. What we're doing is we're exciting these electrons or these molecules to these higher energies. When they discharge, when they relax back down to their ground state, they emit a photon, and it's proportional to the energy separation. So hydrogen may have an energy separation that has a couple different bands in it. Helium, for instance, or neon, let's do neon, which is what we mostly recognize in neon lights. We call everything neon. It's not necessarily that. Neon, instead of having the lines maybe like this, maybe the lines are a few more of them, they're a little bit closer. So when I turn this guy on, you'll see that the color instantly looks different. And if I put the spectrum up on it, you can see that the lines that we're producing, these spectral peaks, are at these particular wavelengths. They're in different locations, and actually you'll see probably a few more of them than you did for the hydrogen. So each one of these elements has its own unique spectra. And this is a very powerful tool that we can use. As I said, astronomers can figure out what stars are made up of, or meteors are made up of, by looking at the light that's produced by them. So you're going to be tasked with the same thing. You're going to be asked to look at these different spectra, determine what's going on with them, and once you get comfortable matching this spectra to a chart that contains it, something like this, you can start to see that what you get in the lab is going to be able to be referenced off this chart. And the last thing we're going to have you do is you're going to be given 3 unknowns. And the unknowns are somewhere on the chart, and you're going to have to figure out what the spectra looks like, and then by that spectra determine what the element is. And here's the little thing. I'm not going to tell you, but some of these may have more than one element in it. So be careful when you're doing this. I'm not saying that they all have more than one element. Maybe none of them have 2 or more elements. Maybe all are single elements. So have fun when you're doing this lab, and good luck looking at light.